Okay, Assalamualaikum warahmatullahi taala wabarakatuh. Okay, so now we continue with chapter calculus in mechanics. So in notes kita assume dia sebagai chapter 5. Okay, tapi kalau kita tengok dalam scheme of work, so calculus in mechanics ni include dalam chapter 6. Okay, so the learning objectives for this chapter. Okay, at the end of this topic, you should be able to understand the relationship between displacement, velocity, and acceleration using calculus, and then solve motion-related problems using differentiation and integration. Okay, so it means that for this topic, okay, apa yang kita dah belajar dalam chapter 1, 2, 3, 4, 5. Okay, so kita akan apply calculus. So kita akan tengok relationship antara displacement, velocity and acceleration, and then we also can solve motion by using differentiation and integration. So differentiation and integration ni kita dah belajar dalam calculus 1 and calculus 2. So now we need to apply in mechanics. Okay. So the subtopic for this chapter are an introduction, okay, velocity and acceleration as a function of time, motion on the plane on the ij plane, velocity and acceleration as a function of displacement, and last one, acceleration as a function of velocity. So kita nak tengok kaitan antara displacement, velocity and acceleration. Okay, introduction. In most realistic situations, forces and accelerations are not fixed quantities but vary with time or displacement. In these situations, algebraic formulas cannot do better than approximate the situation, but the tool of calculus can give the exact solution. The derivative give the instantaneous rate of change of displacement or velocity, or the instantaneous rate of change of velocity or acceleration. So, kadar perubahan displacement ataupun kadar perubahan jarak tu kan, kedudukan adalah bersamaan dengan velocity ataupun kelajuan, and then kadar perubahan kelajuan adalah sama dengan acceleration ataupun pecutan. So kalau dalam bahasa mudah maknanya bila laju kita berubah, maknanya dia ada pecutan lah, sama ada pecutan meningkat ataupun nyah pecutan. So yang tu maknanya perubahan dalam laju, and then bila perubahan dalam displacement ataupun kedudukan, dia adalah sama dengan laju, maknanya bila kita berubah kedudukan maknanya kita akan ada kelajuan. So the key concepts here, acceleration is the derivative of velocity with respect to time. The slope of the tangent to the line of a graph of velocity versus time is the acceleration. Okay, so maknanya apa ni kat sini, acceleration ni adalah pembezaan untuk velocity berkait with respect to time, yang berkait dengan masa, and then velocity ni adalah derivative of displacement with respect to time, and then the slope of the tangent to the line of a graph of displacement versus time is the velocity. Okay, so this one, velocity and acceleration as a function of time. Okay, so kita nak tengok kat sini velocity and acceleration. So in chapter 3, the motion of a body in a straight line with uniform or constant acceleration was considered. The 4 uniform acceleration formula could be used. Okay, so kita akan ada 4 formula yang kita dah biasa tengok sebelum ni. Okay, which are, okay, first V equals to U plus AT. Okay, yang ni formula untuk velocity, and then second one pun formula untuk velocity, V square equals to U square plus 2AS, and then third one for displacement, S equals to 1 over 2 U plus VT, and then fourth, S equals to UT plus 1 over 2 AT square. So we have this 4 formula for velocity and displacement. Okay, so if the acceleration is non-uniform, maknanya dia tak seragam, maknanya pecutan tu tak seragam, differential equations and calculus must be used in place of these equations. So the velocity is equals to rate of change of distance, or V equals to ds dt. Maksudnya velocity ni ataupun kelajuan adalah kadar perubahan jarak. So kadar perubahan jarak. And then another one is acceleration is rate of change of velocity. So it means that this one maknanya pecutan adalah bersamaan dengan kadar perubahan hal laju, ataupun kita boleh differentiate dua kali untuk distance. So kita akan dapat acceleration. So kat sini maknanya kalau awak cari ni, dia akan, maknanya awak kena bezakan dua kali, awak akan dapat acceleration. Kalau awak bezakan distance sekali, awak akan dapat velocity. And then bila awak bezakan velocity, awak akan dapat acceleration. So in all the work examples in this chapter, the letters A, V, S and T have their usual meaning and SI units are used throughout. So kat sini ni kita akan gunakan A for acceleration, V for velocity, S for distance and or displacement, and T for time. So it means that this one, kalau awak dapatkan apa ni, V, so it is equals to ds dt. And then kalau awak differentiate sekali lagi, dia akan dapat d square s dt square. And then A is also equals to dv dt. Betul lah, maknanya awak bezakan ni, awak akan dapat dv dt, this one d square s dt square. Okay, so faham yang ni kaitan antara velocity and acceleration. Okay, next. Okay, in order to obtain an expression for the velocity when the acceleration is given as a function of time, the process of integration has to be employed. So, kita dah tahu dah, differentiate dengan integrate, dia saling berkait, dia adalah inverse. So, it means that this one, kalau awak nak dapatkan balik, kalau acceleration, dia adalah differentiate untuk velocity. So kalau awak nak dapatkan velocity, awak just integrate acceleration. So same with this one. Okay, awak nak dapatkan velocity, awak differentiate displacement. So to get displacement, you need to integrate velocity. So yang ni lah kaitan displacement, velocity and acceleration. So kalau awak tengok daripada the relationship between displacement, velocity and acceleration can be expressed as follows. Okay, so it means that this one, so displacement, so kalau awak differentiate this one, so dia dah akan dapatkan ds dt, so dia akan dapat velocity. And then when you differentiate velocity, which is dv dt, so you get acceleration. So if you integrate dv dt ataupun acceleration, awak akan dapatkan velocity. And then if you integrate velocity, so awak akan dapatkan displacement. If you integrate velocity, so you get displacement. Yang ni if you integrate acceleration, you get velocity. So dia kaitan lah, dia inverse kan. So kalau kita nak dapatkan displacement, differentiate, nak dapatkan velocity, differentiate displacement. Nak dapatkan acceleration, differentiate velocity. Nak dapatkan velocity, integrate acceleration. Nak dapatkan displacement, integrate velocity. Okay, so this is the relationship. Okay, let we discuss example 1. Okay, a body. Okay, example 1. Okay, a body move in a straight line such that s equals to 4t square minus t cube. Find s when t equals to 3. So, since dia dah bagi dah function untuk displacement, so bila dia nak cari displacement which is s, so awak just guna je lah yang ni, s equals to 4t square minus t cube. So when t equals to 3, so you just substitute into this equation, 4 3 square minus 3 cube equals to 9. So the displacement s is 9 meter when t equals to 3 second. So kita terus dapat lah sebab dia nak s. Okay, but for question B, dia nak v. Okay, sedangkan dia bagi s. So we know that kaitan antara s, v dengan a kan. Okay, dia ada kaitan antara s, v dengan a. Okay, nak dapatkan yang ni, this one you differentiate. This one you integrate. So from s to get V, so nampak tak, kita guna differentiation. So to get V, you need to differentiate S, which is ds dt. So awak ingat rajah ni senang kan? Nak dapatkan S, V, A. So S ke V kena differentiate, V ke A kena differentiate, A ke V kena integrate, V ke S kena integrate. So nak dapatkan S ke V kena differentiate. So it means that you need to differentiate S, which is 4t square minus t cube. So differentiate 4t square, you get 8t minus 3t square. So yang ni equation for V. So when t equals to 2, so just substitute 8 times 2 minus 3 times 2 square, so equals to 4 ms negative 1. So the velocity V is 4 ms negative 1 when t equals to 2 second. Okay, so another one, C, you need to find A. Okay, A kita dah ada V kat sini, so just differentiate and you get V, which is 8t minus 3t square kan. This one is V, 8t minus 3t square. So just differentiate this one to get A. Okay, differentiate 8t, you get 8, and then differentiate 3t square, you get 6t. So 8 minus 6t, the equation for acceleration. Kat sini kalau tak nak tulis pun tak apa, sebab dia just step by step je kan, dia tunjuk. So awak direct tak apa, ds dt equals to 8t minus 3t square. So A equals to 8 minus 6t. So we need to find A when t equals to 1. So you just substitute when t equals to 1. So A equals to 2 ms negative 2. So yang ni unit untuk acceleration. This one unit untuk velocity. So untuk differentiate, integrate, saya rasa kalau simple equation you all dah mahir kan. Okay, untuk simple integration and differentiation. Kalau tak, refer balik buku calculus. Okay, so this one for example 1. Okay, the acceleration A is 2 ms negative 2. So you can try solve this one. Example 2. Okay, example 2 dia bagi V. Okay, V equals to 2t square minus 11t plus 14. Initially, the displacement of the body is 50 meter from the origin. So, dia nak initial velocity. So, kalau initial, bila ada perkataan initial, it means that t equals to 0. So awak kena assume sendiri, walaupun dia tak letak when t equals to 0, tapi dia kata kat sini initial velocity. So initial ni maknanya yang mula-mula sekali. Okay, initial velocity. Okay, so awak assume terus t equals to 0. So you get the initial velocity. Just ganti dalam V sebab dia dah bagi equation V kat sini. So the values of t when the body is at rest. Okay, so yang ni pun dia macam hindi, dia tak bagi direct macam example 1. Okay, kalau awak tengok example 1 dia bagi direct. S when t equals to 3, V when t equals to 2, A when t equals to 1. So example 2 ni awak kena fikir sikit, nak cari apa maklumat yang diperlukan. So kat sini kalau dia nak initial velocity means we want to find V when t equals to 0. Yang ni sebenarnya soalan dia. And then B, the values of t when the body is at rest. So when the body at rest, velocity is equals to 0. So awak kena cari time. So V ni kita assume equals to 0. Sebab apa assume equals to 0? Sebab dia kata body at rest. Maknanya dia tak ada kelajuan, dia tak bergerak, dia tak ada perubahan displacement. So bila dia rest, dia tak ada pergerakan kan. So dia tak ada displacement. So maknanya S dia tak ada, maknanya V dia equals to 0. So kita assume 2t square minus 11t plus 14 equals to 0. So just you solve the quadratic equation. So you get t equals to 2 and 3.5. So the body is at rest when t equals to 3.5 and 2. Okay, this one the acceleration. So kalau awak nak acceleration, maknanya dia dah bagi V. So daripada V nak dapatkan A, kena differentiate. So 2t square minus 11t plus 14 is equals to 4t minus 11. So substitute t equals to 5. Okay, and then last one the displacement. Dia nak S. Okay, so kita dah ada V tadi. V is 2t square minus 11t plus 14. Okay, bila dia dah ada V, kita nak ke S. So ingat susunan dia susunan dia adalah S, V, A. Okey, tadi first dia nak daripada dia bagi V, dia nak cari A. Okey, dia bagi V nak cari A. So this one kena differentiate. Okey, sekarang ni dia nak S, dia bagi V. Okey, dari S dia bagi V. So kat sini, so you need to integrate. So awak kena integrate lah velocity. So integrate 2t square minus 11t plus 14. Okay, so tengok balik formula integration. Kalau 2t square dia akan jadi 2t cube over 3 minus 11 t square over 2 and then plus 14t plus c. So yang ni untuk indeterminate integration kan. So kena letak plus C. So information given T equals to 0, S equals to 50. So sebab dia kata bila T initial kan, initial, so this S equals to 50. Dia bagi tahu dekat sini. Displacement of the body is 50 meter from the origin. Initially, maknanya dia berada 50 meter. Maknanya kedudukan dia 50 meter. So, maknanya kita assume bila T equals to 0, S dia equals to 50. So, you substitute into this equation. Masukkan dalam equation yang awak dapat ni. S equals to 2 over 3 T cube. So, semua T gantikan dengan 0. S equals to 50. So, you get the value of C. So, kita nak dapatkan C kat sini. So, when you solve, you get C equals to 50. So, when T equals to 6, sebab soalan ni dia nak 6 kan. So sebelum awak cari 6 ni, awak tak boleh direct cari 6 lepas cari S. Sebab apa? Kita ada C ni kat sini. Kita ada constant, unknown constant which is C. So nampak tak? Kat sini kita ada C. So kalau awak, walaupun awak dah dapat S kat sini, awak tak boleh direct ganti T equals to 6. So you need to find the value of C. So nak cari value of C, kena cari information yang ada dalam soalan sebelum ni. So kita ada yang ni information kat sini to get the value of C. So bila dah dapat nilai C, baru gantikan dulu dekat sini. So baru awak boleh cari S when T equals to C. So the answer is 80 meter. Okay, so this one for example 2. Okay, so yang ni untuk velocity and acceleration. Okay, so next topic is motion on the IJ plane. Okay, if motion with non-uniform acceleration takes place in the IJ plane and vector notation is employed, the same methods as in the previous examples may be used and each component can be differentiate or integrate separately. Okay, so yang ni kalau dia based on IJ plane. So, kita tengok dekat example 3, if S equals to T for I plus 3 over 2 T square J. So, dia beza kat sini je. Dia ada I dengan J. Okay, kalau sebelum ni, kalau awak tengok example 1, example 1 dia just S equals to 4T square minus T cube kan. Okay, so kat sini dia just tambah I dengan J. So, how we solve this one? Dia kata find S when T equals to 5. So, given S equals to T 4I plus 3 over 2T square J. So, awak just buat macam biasa. Just substitute T equals to 5 into this equation. Okay, so awak still dapat dalam I dengan J. So, gantikan kat sini 5 power of 4, 3 over 2, 5 square. So, you get 6 to 5I plus 75 over 2J meter. So, the displacement S is 6 to 5I plus 75 over 2J meter and the distance travel is, okay, so kalau untuk distance, dia lain kan dengan displacement because displacement is a vector. So, dia boleh tulis dalam bentuk I dengan J. So, dia ada unit I dengan J. But for distance, awak boleh kira untuk magnitude. Okay, so cara nak kira magnitude, just calculate 6 to 5 square plus 75 over 2 square, square root. So, your answer is 6 to 6.12 meter when T equals to 5 second. So, yang ni cara kita nak cari sebab dia lain kan, distance dengan displacement. Displacement is a vector quantity but the distance is apa ni, dia bukan vektor quantity. Okay, then dia skala kan. Okay, distance is a skala quantity, so dia tak boleh dalam I dengan J. Okay, next is V when T equals to 3. Okay, so sama juga bila you are given S, so if you want to find V, you need to differentiate. Okay, differentiate S. So differentiate T power of 4, you get 4T cube. And then differentiate 3 over 2T square, you get 3T. So yang ni still lagi jawapan dia dalam I and J. So when T equals to 3, so you just substitute into your V. So gantikan tempat T equals to 3. So you get 4, 3 power of 3I plus 3J, so you get 108I plus 9J ms negative 1. So nak cari velocity ni boleh guna dalam ni sebab velocity adalah vector quantity. So velocity dia boleh dalam sebutan I and J. Okay, but for speed, so kan kita ada dua version kan untuk vector and skala. So untuk speed, so awak kena cari magnitude, which is 108 square plus 9 square square root, so you get 108.37. So dia lain kan, dia ada kat sini. Saya ulang balik, kita dah belajar dah sebelum ni. Okay, kita ada vektor dengan skala. So kalau kat sini displacement, kat sini adalah distance untuk skala. Kalau yang ni adalah velocity, kat sini adalah speed. Okay, and then this one adalah acceleration. Tapi acceleration dia adalah vector, dia tak ada untuk skala quantity. Okay, then last one is C. Okay, A when T equals to 4. So samalah sebab awak dah ada S, and then kita dah cari V, which is 4T cube plus 4T cube I plus 3TJ. Okay, so to get A, you need to differentiate V. So 4T cube dapat 12T square, and then 3T you get 3. Okay, 3J. So when T equals to 4, you get the acceleration is 12, 4 square plus I plus 3J. So you get 192I plus 3J. So kat sini awak just dapat acceleration sebab untuk pecutan dia cuma vector quantity, dia tak ada skala quantity. So you get the answer here, the acceleration. So tadi pengiraan dia just sama je kan. Okay, so yang ni awak boleh try solve untuk example 4. Sama juga macam tadi. So boleh, yang ni boleh dapatkan acceleration. So you need to know how to differentiate or how to you need to differentiate or you need to integrate. So yang ni macam B ni kena integrate kan. Okay, kena integrate. This one A kena differentiate. Sebab yang ni dia bagi equation untuk V, and then S, dia bagi V dengan S when T equals to 0. Okay, so kat sini dia nak cari S, so given V, nak cari S kena integrate, and then this one kita nak cari constant C. So kita guna information when T equals to 0, S equals to 18I minus 24J. Yang ni diberi dalam soalan ni. When T equals to 0, S equals to 18I minus 24J. Okay, so you make an equation here. So you get the value of C. So ganti tempat C, which is 18I plus minus 24J, and then you get S, baru gantikan T equals to 6. Okay, so you can try solve tutorial 5A. So you can complete here for velocity and acceleration. So kat sini ada banyak soalan untuk velocity and acceleration as a function of, kat sini yang ni tajuk dia untuk this topic, velocity and acceleration as a function of time.